Hi, in this video I am going to go through the ggplot exercise for week 6 of spring 2024. In this exercise, you took turns going through just iteratively more complex ggplot creations. And the reason I did this is because that really mimics the behavior that I do on a really weekly, daily basis of utilizing ggplot to visualize my research. So to do this, we started off with just a built-in data set because it is a little bit more simple. So that data set is MT cars. If I can grab, all right, we'll just go back here. MT cars, we'll pull up in a second, but it looks like this. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different columns. Each of those columns are numeric. One thing about MT cars is it also has the names of a bunch of cars built into it, but those are the row names. There'll actually be a step later on where we use those names, but in order to access them, we'll need to create a new column, or at least that's the simplest way to go about things. In this first question, I am asking you to create this plot. In the original version, you don't have, or in the other version, you don't have this answer. But the reason why I know how to start is because I've memorized some of these early steps. Later on, you do a lot more experimentation and slowly you just kind of develop a sense for it. So if this is the image I'm trying to create, let me scooch my screen over a little bit so that I can use it as a reference. I'm going to always pretty much start off with ggplot, but in order to do that, I first need to call library on the ggplot2 package. I'm currently getting a message that it was built for our version 4.3.2. I'm on 4.3.1. That should be all right. If it's not, well, base ggplot stuff still probably going to work, but some of the more advanced stuff might not. However, to start off with the ggplot, it's easy. You just start off with the ggplot function. Now, please note that's ggplot2. This is just ggplot. There's a difference. The letter, that number matters. That's the number of the package. But the function to start off with ggplot is pretty much always the same. So the data in this case is MT cars. The second argument in ggplot is the mapping argument. I can specify it, or I can just rely on the order. Here, the order of arguments to AES, and if you can read that tiny little text up there, it says X, then Y. If I press tab, I can see X, then Y, then ... That means anything beyond X and Y will have to be named. But X and Y can just be placed in order. So MPG, HP, and let's just test to make sure everything's working so far. Okay, yeah, we're getting a plot. That's what we're looking for. It's got MPG down here. It's got HP up here. Hey, even my aspect ratio is pretty similar to what I had over here. At this point, let's just try adding in these dots because that's kind of the simplest thing. I start a lot of my bivariate, so 2 variable plots off by just adding points and seeing how that looks. Geopoint, not points. I do that every time. Okay, so I'm seeing this relationship that all tracks. The major difference so far is that this has color, this one does not. In order to name color, I can specify it here. I could also come down here, use the first argument to change the mapping of just geopoint to color. Either one will work. I'm going to do it up here because it gives me a chance to demonstrate some other behaviors. So I'm going to say color is going to come from the displacement, and is that DISP. I'm going to add a line break just so that this is all a little bit easier to see. And I enter into kind of a fairly familiar pattern if you've been following along in class. All right, so far I have my geopoints, I have my color, I have my X, my Y. Background's still gray, so I didn't add a theme BW. This last leaves the smoother. Technically, this is what's called a spline. It's a word that comes from shipbuilding, where you put little weighted weights on the wood that went along the spine of the ship. And then this weights would weight down the wood and it would conform to the shape of the ship. Well, that's kind of what a spline does, is it takes a weighted average that as you move across this point, all these points are kind of shifting it over. There's a certain amount of flexibility to it. There's a lot of other parameters I don't ever ask you to go into in this class. It's a whole topic in itself. But in the end, it draws a flexible line that kind of fits the general shape of your graph. Kind of useful for seeing trends. I often use this function for drawing linear models, which obviously this is not a linear model. All right, so I get a few messages when I plot this. I get that it's using method equals los. That's just a form of like how to do this fitting. And the formula that X, or y is going to change as a function of y. That's just how you would read that. That's fine. Those are things that if we specified in the geom smooth, this message would go away. But this isn't even a warning. This is just telling us what it's doing. This one is a warning. This is saying that ggplot had to do something different for this function. That specifically, the aesthetic had to be dropped during statistical transformation. So for the record, you didn't tell it X and Y coordinates for this geom smooth. It calculated it for you. So it did statistical transformations for you, which is beautiful. But when it did that, it couldn't figure out how to utilize the color, which I think makes sense to most students. What color would it be? There's lots of different colors. Would it shift color slowly? Would it be based on the average? Maybe some of those are a possibility. I don't think they are, but you could probably figure out a way to do it. However, in the end, what ggplot does is it just ignores it. It just says, hey, I'm going to drop that change the color based on displacement concept because I don't know how to do it. So one thing that you can do to overcome this message, if that warning message bothers you, is you can just specify your own color for this. So you could just say like, all right, well, it's kind of bluish. Let's just make it blue. And now it doesn't give me that warning message. And what's going on is that by specifying the value here, you're overwriting this mapped value, which has been connected to a variable, which needs to change. Well, I can change the color. I just can't change it as the function of one of these columns in the data because that would be much more complicated math, and that's not the instructions it knows how to deal with. Yeah, hopefully that made sense. This next one has you start to iterate on this. So it's going to have you, there we go. It's going to use the same y, same x. I'll keep that the same. Displacement's the same. It still has a smoother, although one thing to note is the dots are on top of the smoother. So I'm going to switch that order there. Order does matter in ggplot. So with that, now my dots are on top of the line. Cool. There is a additional mapped aesthetic though. So here we can see that the weight is being used to make the dots small or large. And so that is going to be variable. So anytime we have a variable, you should be thinking of these aesthetic sections. So in this case, I just added a comma because this is an additional argument to the AES function. I then connected the concept of size on the plot to the column of WT. When I do this, I get yet another message that the following aesthetic was dropped during statistical transformation. So one sec, my dog is freaking out. Can I pause? All right, sorry about that. So coming back over here, the WT is already changing now, so that's good. We're ready to move on. Now, I think the only difference, and pardon me if that's not true, we'll get there, is now the color palette being used. So in this case, I'm going to add scale color viridis. And I'm going to do C. There's actually 3 different options. There is B, which stands for bend. It's kind of cool looking. Here's what bend looks like. So it bends the ranges into distinct values. I actually find it one of the most useful tools. I've kind of used it more and more lately because I just find this much easier to interpret than the gradient. Although the gradient is, definitely nice and a little bit more scientific. But it's hard to tell the difference between subtle changes in color, at least for me. Some people probably have better color vision. However, I had used C. We could tell that by the smoothness of that. The order of the legends, that just seems to vary between computers. Not a big deal. Not a big deal. In the end, there is a way to force it to be a certain order. I don't even remember how to do it. I looked it up once. I don't know why I spent time on it. This is just kind of general like career advice. In that situation, just go into MS Paint. You can always just flop their places later on. You don't need to go spend 3 hours of doing research if that's it. I have an invisible cat on my shoulder. Okay, so last thing is I'm still getting this warning message. So now it's for the same message, but for size. Easy one to fix. It's the same concept as we can just overwrite the mapped aesthetic so that it uses a single size and it won't complain about not knowing how to vary the size anymore. And if we wanted to, we could make that larger. It would be larger. I'm going to make it back to 1. Okay. So next up, we added some text to this. Now, I don't think any other changes were made, but the text is somewhat controlled. So to do that, you're going to first have to load a library. I'm going to add it to my library section up here. I don't even know if on this, I do have it installed on this computer, but if I didn't, I would use the install.packages quotation marks ggplot2 function. So that right there would install the package for my computer. But once I load it, it says it's built, it's working. It does give a message that it was built for a newer version, but that's all right. So I can just start off with, if I really don't know what I'm doing, geom label repel. I can just add it and kind of follow along with the error messages. So let's see what we learn. I'm gonna try to make that a little bit bigger. And there we are. Okay, so this one is not a warning. All right, Riker, you can't, come here, come, give a good face to the camera. Oh, okay, nope, he's not feeling photogenic today. Just wanted his tail in the picture. Make that a little bit larger too, so we're not going off screen. Cool. So the message down here is an actual error. So an error is different from a warning. Errors mean it did not work, and we can see that that's true. The plot is now empty. Now, if we think about it, you hopefully even predicted what this would be. I forget about this all the time. So I would, if you didn't predict it, no big deal. But it's looking for an aesthetic called label. And that's makes sense because what else are you going to label it with? It doesn't know what to label it with. Now, it turns out you probably could, and I don't even know if this will work, so let's just try it and find out. I could try to call the row names of empty cars, and this might work. No, it did not like it. Let's try that one more time. I'm not sure what the viewport is. Yeah, it's not liking it. I'm not sure if this is why, but let's go try it out. Typically in ggplot, you want to be making variables using columns, not using data that's coming from elsewhere. So what I'm going to do is I'm just going to modify empty cars so it has a column called names. So this is just syntax that we've studied numerous times at this point, extracting the name of currently a non-existent column and assigning that column values. That just adds in that column. So that's what happened. So now I can add names as my label column, and let's try that again. All right. So I'm still getting a message. The following aesthetics were dropped during statistical transformation. label. Okay, well, we can fix that one. This is a sign. This is coming from the geom smooth, it turns out. So what I could probably do is, instead of adding it here, well, we could just try adding label equals null and see if that works. No, that one didn't work. It didn't like it. We could go into the mapping of smooth, and we could try label equals null here. That one it did like. So that is like the way to get rid of that message. Again, that was just a warning. This is the current error. Viewport has 0 dimensions. I'm guessing it's just because of this. What I'm going to do is I'm going to come in here. I'm going to run dev.off. That's going to close the graphics device. And now if I try it again, it's resolving. So this is just an issue that happens sometimes. It was probably just because my screen was all kind of scrunched together because I'm trying to do this recording. At this point, we can see that it's not really the data that I wanted to visualize. And by the way, just to show you that this was not actually necessary, I am still getting this message, but again, that's just a warning. No. If I come into here, this is probably the other way I could have done that without inspiring that warning, and that's by just giving the label to the mapping argument inside of geom label repel. So again, it's got to be inside of an AES, and then I'll just say label equals names, and now that that's there, I can remove it from here. Looking good. Looking good. So at this point, we are now seeing that there's a problem, that my plot is far too busy. So let's say I wanted to restrict this to just the cars that have a certain property. So I think in the question I said a miles per gallon greater than 25. So that should just be these, over there, right there. So in this case, I would need to change the data being used to do the plotting. Instead of using all of the data, so all of empty cars, I will restrict it to just empty cars across rows where it is 25 or greater. I don't remember. We'll flip back to the question and verify that in a minute. But when I do that, that's going to restrict what data goes in. As typical, I should kind of just be checking this as I go through. Okay, that's working. I'm getting a bunch of logic. This is just warnings from the plotting. If I check the extraction's working. That looks good. So I should see these values getting plotted. Sorry, these values getting plotted. All right, let's see how that works. All right, I knew this was going to be a problem. Here, I'll put myself in the middle. Weird. I'm just going to go off screen. So, there I am. I'll be a weird, hovering, disembodied head. Love it. All right. At this point, I can see that some of these are too small. Some are larger than others. That's because it's changing as a function of the size. That's an easy one to overcome. So if we don't want a mapped aesthetic, we could do a few different things. We could just put the mapped aesthetic into the function we do want it, like is what we did here. Or we can overwrite that aesthetic for the functions that we don't want to vary. So in this case, let's say I want the size to be, I don't know, 6. We'll just guess. I know this is a bad guess, but you don't know that yet. You just had to play with it. Actually, that's not bad. Different computers, different resolutions. I forgot that this computer has a higher resolution than I typically work with. So 6 doesn't look terrible. It's not great. It's a little big. It wasn't as bad as I thought it was going to be. Let's just drop it down to 4. See how that looks nice. It's legible. The font is, somewhat similar to this, but a little bit bigger. Cool. It is changing colors. You might not be able to tell. Honestly, I don't think I would normally change this. I kind of like the slightly plum text. But if you wanted to, you could have like black color. So that's technically changed. You might not be able to tell. Here, I can do red. All right, obviously changed now. And then there's one other thing is in my plot, I changed the alpha. And the reason I did that was just to allow you to kind of see, even though geom repel does try to push things away from the dots, here I have pushed them away and made them a little bit transparent, although they're still drawn on top. It looks a little too transparent. Let's, all right, that looks better. And then, finally, this is, again, getting into the art of things. There's not really a right answer here. There is an argument called min segment length, one of my favorite arguments, because what it does is right now, like this Porsche, I don't really know which one of these is a Porsche. If I didn't know that I was only drawing based on MPG, I wouldn't know that it belongs to that one. But with minimum segment length equals 0, it does draw a line for everything if it is 0 or more units away from the dot. And so that means everything gets a line, making it easier to see. One of my favorite tools. And I think I would normally then plot a theme BW, but let's go see what I did in the question. No, that was the end of that, so I will stop there. Let's see, how close did I get? I used black. I used size 3. I remember that one. Alpha 0.8. I was pretty close. Again, this is just getting at kind of what you think looks good. I like to be able to see that that dot is there. I like to be able to make sure I see the right side of that dot. You can't see it right now, but when you zoom in, it's going to be a lot more obvious. And I think that alpha gives you a little bit more aesthetic pleasing approach. Just don't go crazy with it. It can get kind of intense. All right. Was there a required question here? Oh, all right. Well, I'll have to go fix that. Sorry. Just going to click something for everything. All right, there we are. So this next one has you generate some data to do this. Oh, nice. I'm not using my very slow computer, so this should go a little bit faster. So I'm going to generate the data. Set.seed is going to make this predictable as long as they're all run at once. So if I do this, even though it's generating random data, the values for C here end at, say, like 17.937. And if I generate random data again, and then I look at C, it's that same value. So that's the point of set.seed. If I change this, it's now a different set of random values. That's the point. Pseudo-random number generation. Turns out random is really hard for computers. How's it going to do it? Complicated maths, that's how. All right, so then we look at the head. We look at the tail just to help you visualize what's going on. I've just got 2 columns that are combined using rbind from these 3 different data sets. Now, this is just us showing that we can plot these. I have to first sample it because even with 5,000 dots, it's still going to take a second to plot. If I plotted all the 20, so 1, 2, 3. So if I did all 60,000, it would have taken a lot longer. Okay. So the first thing I asked you to do was create a histogram from some of these different plots. So I said stuff like plot this gray as the values from the X column, plot the red as the values from the Y column. I used a bin width of 0.5, and there we are. So starting off, we got our ggplot function. It's going to need 2 arguments. It's going to need data and mapping. So the data is going to be df1. The mapping is going to be, we could just leave it blank. This isn't the solution I proposed in the form, but let's just try and leave it blank. I'll show you what this alternative solution looks like. So at this point, we're going to have to tell everything what to map to what, but I'm just adding geom histograms to this. And I'm changing the mapping, which currently doesn't exist, so that it uses the X column. Let's just take a look at that. Oh, doesn't like that little asterisk being there. Cool. So if I then wanted to add on a second histogram, but using the Y column, that works. Right now they're the same color. So if I want to make one a different color, just make it red. There we are. Oops, color only colors the outside surface of geom histogram. I don't know why, but fill is actually the concept used to fill it with a different color. Okay, we're now getting pretty close to this one. We got a few other details to fill in. Ha. That wasn't even a joke. That was nothing. And so I made it transparent on this one. So that's that alpha argument. And I want to point out the reason I am doing all of this outside that mapping, this is a common source of confusion, is that I don't want them to change. The stuff outside is static. It doesn't change as the function of something else. It just is. And so that makes sense. This one should change, that each value, each row in my original data frame had a different Y value, but each row should be filled red from this data. And that's how that works. In fact, that's how geohistogram expects. If you gave it a vector here of multiple values, it would probably get confused if it would work at all. So at this point, it's looking pretty good. There's a few other little tweaks I made. I added that the bin width was, what did I actually make it? Move my head. Nope. Oop. It was the opposite. There we are. We'll point with my head because that's weird. 0.5. So there we go. Yeah. All right, I'm gonna stop that. So sorry. So bin width is 0.5. Wow. Let's do that. 0.5. So that means each of these little horizontal sections, so those are the bins, those are going to be drawn at 0.5. I want you to note what happens when the bin width is different for one histogram versus the other. Because these bins are wider, they encompass more data points, and so their count is larger. It's a subtle thing that it can be really abused even to like make a point. So this isn't any higher, it's just that the bins summarize more information. Get into the ethics of plotting. All right, now with the bin width being equal, we see that original relationship restored. This is starting to look a lot like what was in my picture. Yeah, it's looking pretty good. I have some other little details. Let me add a line break there because we're getting too wide. Line break, there we are. I'm gonna add a plus, theme BW, one of my favorites. Give us this nice clean black and white theme, looking good. And then I said position X in gray, Y in red. And so I'm just going to use the labs for that. There's a number of different functions you could have used to do this. Position. I could do a line break if I wanted. That'd be fun. We'll just demonstrate that. X in gray and Y in red. So that little \n adds a line break within my text. It's a handy tool in your toolbox, not something that's necessarily gonna be needed. All right, that's looking pretty similar. So I think I'm ready to move on. At this point, I then say, hey, can you draw some lines to show the means used to generate this data? Sure, I can do that. Pass Nolan, no problem. So the function used to draw lines, which you would probably only know if you went and did some research, but it's not hard research to do. It's a very common tool. It's well documented. Let's see, this is geom V line for vertical line. There's a H line as well if I wanted to draw a horizontal line. And then my norms or my means were 10, 20, 15, and 30. Yeah, 10, 20, 15, 30. All right. $10, 15, 20, 30. All right, let's just draw those and see how that looks. All right, those are hitting all correctly. I could change the color of those. I don't know. Let's just do it in black, 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 red. And then since this one is two different means on top of each other, I'm just going to double up here and then give one a black color and one a red color. But here's the deal. You won't see one. So just a heads up. You're not going to see it in just a second. But then we're going to fix that. All right. So let's just test that out. I made each of these a separate argument. That's not what I wanted. So I made the color black, and then I just said black, black, red, red, and ours just like, what? I'm gonna ignore this. a weird decision. I think it would make more sense to produce an error, but I can understand why they did it, just from someone who's spent some time programming and knows how hard it is to interpret what users will do. Okay, so now that I've encapsulated it into a single vector that is the same length as this vector up here, I think that should work. It is. Now, like I said, this is being plotted on top of the other black line, so you're not seeing it. So how can we fix that? Well, it turns out if you went in and did some research, one of these ... dots is line type. Okay, I think that's right. We'll find out in a second if that's right or not. It'll probably tell me to use something else. So I'm just going to do 1, 1, 1, 2, 2. So for the black, the black, the black, the red, and the red. So the different means for the different distributions. Okay, so with that, I can see that this is a black line underneath a red dotted line, but that's a little bit hard to see. So let's do one more modification where we change the size to be larger. And with that, we have a pretty good similarity. There is a difference though. This one has these smooth lines, and this one has still the histogram. The difference here is that these were a density plot. So a density plot uses math to calculate a smoothed density of points underneath it. It's great if you don't want to have to try bothering with stuff like matching the bin width, or you have decently smoothed data that you would like to have visualized with a little bit of a prettier graph. An interesting thing is that with base R density plots, you can also then do math on the density function. And so I can do things like look for peaks. I've actually used that quite a bit in one of my previous publications from that mapping paper, if you ever want to go read it. But anyways, what we're going to find is this produces a warning. Yes, it was a warning. It was not an error. We'll come back to that warning. Let's get this thing filled. So I'm just going to give that a fill of, I don't know, let's try black, see how that looks. Oh, too dark. Gray 20. Still too dark. Gray 50. This is going to be exactly in between black and white. Looking better. Yeah, I think I kind of like it with the lighter color. So I'm just going to go one more time. Actually, you know what? I'm going to go with gray 80, or sorry, gray 20. But then I'm going to make it 50% opaque and 50% see-through. Oh, yeah, love that. I can see the grid lines back there. Looking good, looking good. So that's what, approximately gray 80 at this point, because it's halfway again to white. Anyways, some weird maths in there, but maybe that made sense to you. I just don't have time to explain. I don't want to confuse you more. So the last thing, what's the last thing? I feel like I'm forgetting something. It looks okay. Oh, the warning message. Yeah, so the warning message is that there's an unknown parameter called bin width, which I think makes sense. Bin width doesn't belong there anymore. So if I take those out, there we go. Looking good. Let me just try that one more time. Oh, it's because my... Sorry. It's hard to do these. Should I be pausing my video right now? Yes. Am I going to? Probably not. There it is. All right, I can see my prompt now. Let's just try that one more time. Yes, there was no error message. Cool. I'm moving on. Sorry for the delay. So this section is just trying to explain why I'm even bothering with some of this. The reason why is like this is clearly not a good plot. So we are often working with data that is just given to you as columns in a spreadsheet. So you like get properties of some biological material. Why am I drifting off the screen? You get properties of some biological material. You don't know whether or not they are the same thing or if they are related in more subtle ways. And so what you do is you visualize it. Visualization is a really great way to take advantage of our incredible visual processing skills, just as humans. And so it allows you to visualize this data and look for trends. So with one-dimensional visualization, I can see where stuff overlaps numerically, but I cannot see at all. Well, I'm going to have to keep clicking back. I can't see at all that this data came from this distribution where they clearly interact in one of three different ways. This is an interestingly discrete interaction. But we don't see that at all with this. In fact, it kind of looks different. It looks like there's, I don't know, one interaction, but that's just artificial. That's not showing interactions at all. That's not how one dimension works. You need two dimensions to show an interaction between two different things. So we visualize with like scatter plots a lot. Because I often want to compare one variable to another. Sometimes I'll even go further and I'll start coloring things or changing the shape or doing some crazier plots. All right. So in this one, I am trying to get you to do a alpha based genome. Now this one will take some computers a little bit longer. So here, this is DF1. My AES is X and Y. I wasn't very creative with my names here. If I just draw a genome point by itself, it's going to take a hot second. Probably going to plot, better plot. There it is. But there was no alpha on this. And so the alpha is really going to change things. Additionally, right now I can see that there is some stretching going on, and that's because I don't have a chord fixed. Too many things. This will make it a 1-to-1 aspect ratio. So if I want to make these, I don't know, 0.2, so those are 2% opaque, so 2% brightness. Let's see what I did in here so I'm not just guessing for too long. I ended up at 0.05 to get what I think looks kind of nice. I'm going to change it to 0.04 because I think it could be a little bit better. And then shape 16. Shape 16 is slightly different than shape 1, which is the default. Shape 16 does not have a ring around it. It's just the inside. And so this right here, if I made this transparent, you would see a lot of opaque rings with transparent insides. But now this is just going to be single transparent circles. Then I made the size equals 2. I'm not going to change the size on this one. I'm just going to leave the sizes as 1. So let me pause this just in case it does take a minute. And there it is. So not too shabby. It went pretty fast. It wasn't very long. I just didn't want you to have dead air. So we can see that there's, gradually getting more and more concentrated as we move inside. It's not perfect. We have like that gray background. I probably should have added theme BW to it. Anytime you're trying to do a like alpha based analysis, I'm always going to be recommending that you use theme BW. I do like the 0.04 though. We can see a little bit further in to the inside of that. Anyways, getting into the art. However, whenever we are visualizing lots and lots of data, especially if I say increase this by an order of magnitude, that would have been several minutes to plot if I could plot it at all. And Geom Bin 2D is explicitly made to help with this sort of scenario where I have a two-dimensional density that I'm wishing to assess. So if instead of geom points, let's just knock that one out. If I do geom, let's do hex. I never use hex. Hex is pretty cool. Let's see if they made it better. It's been a little bit wonky in past years. So if I tried just geom hex by itself, oh man, gotta install something. All right, let's do it. There we go. See, the hexagon's pretty cool, right? Let's see. In this one, did I tell you the size of the bin? No, it's just guessing. That's fine. So if I wanted these hexagons to be even smaller, I think bin width is what I would do. And I would do, I don't know, 0.05. Yeah, so I made my bins a little bit narrower. If I wanted to, I could give it, I believe, a length 2 vector, and I could have some weird shaped hexagons. This may not work with geom hex. I don't actually ever play with it. Oh, it works. Cool. These sorts of questions, students of mine, this is how I do this. Like, this is how I get through these questions. It's this sense of exploration is what I think is really exciting about this topic. So just for the record, what the change was is with a length 1 vector, it applied it to both the x and y axis. But with a length 2 vector, the first vector became my x, the first value became my x, the second value became my y bin width. So now I have these weird elongated hexagons. I don't know what to call them. Hexagons. No, that was nothing, Nolan. All right, cool. So here's our thing. Now, I don't like that blue to darker blue color palette. Never been my favorite. I do enjoy Viridis. It is more colorblind friendly, while still allowing you to do some like more fine color-based visualization. So this, I could try scale color Viridis C. Now, for the record, this won't work. Why? Because this has not actually been colored using the color aesthetic. It's been colored using the fill aesthetic. When I change that fill aesthetic to scale fill Viridis, it looks like this, which is quite lovely. I can see the center of my distributions. I can see that it is fairly random. It's not just coming to a perfect point, although that one does come to a pretty perfect point. But that makes sense. It's random data. And if I go up here and I say have much more data, so let's just say I increase all of these by a factor of 10. Do I dare do 100? What do y'all think? I don't know. I'm going to crash my computer in the middle of the video. I don't see how that could possibly go wrong. Let's try it though. I'm feeling bold today. Ooh, you can see it's struggling a little bit with the R norms. I'm definitely not going to try that geom point. That scares me. My computer would I'd have to just kill ggplot or RStudio. But with this, it's fairly perfect. And because we're generating, what, 200 or 20 million, maybe? It's just 2 million points, 6 million in total. But because of that, we can see that it's a very, very clean distribution. Starting to look like, I don't know, a trinary system out in space. When you can imagine that this is us visualizing data collected over the series of months from some telescopes pointed at 3 stars that were nearby each other in space. That might be true. I don't know. I'm not an astronomer. Don't take my word for it. But it does kind of look like some of those pictures you see, right? Just randomly diffused by hitting interstellar dust, so it kind of spreads out. But on average, it's coming from a single point. Makes sense to me. All right, I'm sorry about this. I'm going to have to go fix this in the plot. I think that's the end of this lesson. They were all just mandatory. I thought I fixed that. All right, that's the end. I hope that helped. It was a long video, 44 minutes, but good luck and good plotting. That's my sign off. Bye.